Hello students, in this lesson, we will learn the ultrasonic testing methods and techniques of pipes and castings. They are introduced separately in the following parts. Ultrasonic testing of pipes. Pipes are commonly used to profiles in engineering and can be divided into steel metal pipes, non-ferrous metal pipes, and non-metallic pipes according to materials. According to the size, it can be divided into small diameter tube and a larger diameter tube, thick wall tube, and a thin wall tube. From the perspective of ultrasonic testing, the pipe with an outer diameter greater than 100 mm is called a large diameter pipe, and a pipe with an outer diameter less than or equal to 100 mm is called a small diameter pipe. It is a thin-walled tube according to the manufacturing process. It can be divided into seamless pipes, welded pipes, composite pipes, etc. Generally, ultrasonic testing is required. Mainly refers to pipes that work in high temperature, high pressure, and special environments for a long time, such as pipes for pressure vessels, pipes for aviation, pipes for oil and natural gas transportation, etc. The diameter and wall thickness of these tubes vary widely, so the methods and techniques used in ultrasonic testing vary greatly. First of all, we should understand the classification of the manufacturing process of the pipe. The manufacturing process of the seamless steel pipe includes the perforation method and the high-speed extrusion method. The piercing method is to pierce the round steel with a piercing machine with rolling, and then flatten it through the manual rolling mill or a seasoning machine. The high-speed extrusion method is directly extruding the raw material with lubricated surface in the extruder, so that the dimensional accuracy of the processed pipe is high. There are two kinds of welded pipes. One is electric resistance welded pipe. The other is submerged arc automatic welded pipe. You can refer to the inspection methods and techniques of welding parts in the previous lesson for comprehending the inspection of welded pipes. In this lesson, I will only introduce the ultrasonic testing method of seamless pipes. The defects in seamless pipes mainly include cracks, folds, delamination, inclusions, etc. During the process of the pipe, the wall thickness direction is deformed by force to be rolled and elongated along the pipe axis direction. So the defects are usually parallel to the pipe axis direction and in the direction of the pipe axis, stretched on the axis. The ultrasonic testing of pipes generally adopts the pulse reflection method. At present, the transverse wave testing is mostly used. The contact method or the water immersion method can be selected according to the specific testing requirements of the pipe fittings. Usually, we want a single waveform in a pipe of inspection, so whether the contact method or the water immersion method is used. It is necessary to ensure that the sound beam is pure shear wave when it enters the pipe. Therefore, they are all obtained by refraction and wave mode conversion at the interface of two mediums with oblique incidence of longitudinal waves. The incident angle is controlled between the first critical angle and the second critical angle, and there are only transverse waves in the pipe. Under the condition of pure shear wave in the pipe, the precondition for the sound beam to reach the inner wall is that the critical T ratio D is less 1/2 times 1, minus the shear wave velocity CS2 in the pipe material than the longitudinal wave velocity CL2 in the pipe material. Therefore, by analogy with the related metals, it is generally used as criterion for the rough estimation of whether the pipe can be tested or by shear wave. The ratio of thickness to outer diameter is less than 0.02. If it is less than or equal to 0.02, it is considered to be dictatable. And this type of pipe fitting is a thin-walled pipe. Next, we will describe the inspection technology of thin-walled pipes in detail. Small diameter thin-walled tubes, it is difficult for the probe to directly couple with the surface of the tube, and the sound beam diverges seriously as the inner diameter of the tube. So it is difficult to use the direct contact method. Therefore, we often use water immersion method. Focusing probes enhances inspection sensitivity and resolution and make it easier to achieve automated inspection. Focusing probes are divided into point focusing probes and line focusing probes. The beam focusing method is selected according to the requirements of the tested pipe. Steel materials, non-ferrous metals, and some rare metal pipes with general quality requirements are usually detected by the line focusing method, while pipes with higher quality requirements are detected by point focusing method. In terms of inspection frequency, it is necessary to pay attention to the influence of inspection frequency and focusing effects. At the same time, it is necessary to consider the accuracy of the mechanical transmission device of the inspection equipment. Generally, the frequency range used by the water immersion method is 2.5 to 10 MHz. There is also an important parameter that needs to be considered during inspection: eccentricity. The eccentricity determines the incident angle of the sound beam, which has a direct impact on the propagation mode, energy distribution, and sensitivity of the sound beam in a pipe. The selection principle of the electricity is: the inside of the pipe wall is pure shear wave, and the shear wave can reach the inner wall of the pipe. The inspection of a large diameter, thin-walled tubes is mainly based on circumferential shear wave inspection. When necessary, axial shear wave inspection and circumferential or longitudinal wave vertical incidence inspection are performed. The longitudinal wave vertical incidence inspection method is mainly used to detect the delamination defects parallel to the axis of the pipe, and the axial shear wave inspection method is used to detect the transverse defects perpendicular to the axis of the pipe. There are two commonly used methods of circumferential shear wave inspection of large diameter pipes: direct contact method and dual probe shear wave contact method. Taking the direct contact method as an example, the contact method is suitable for detecting pipes with a diameter greater than 540 mm. Generally, a frequency of less than 2.5 MHz is used for coarse-grained materials, and 2.5 to 10 MHz of fine-grained materials. The incident angle is adjusted by the probe wedge so that the shear wave refraction angle entering the pipe is about 45 degrees. During the testing process, attention should be paid to changes in sensitivity caused by probe wear or changes in instrument performance. 2. Ultrasonic testing of castings. Castings are parts obtained by melting metals or alloys directly into the mold, and the liquid metal is cooled and solidified in the mold. The characteristics of casting are coarse grains, uneven structure, non-dense, and rough surface. Common types of defects in castings include shrinkage cavities, porosity, pores, sand inclusions, segregation, cracks, etc. Castings are difficult to implement to ultrasonic testing because of their coarse grains, long dense structures, and rough surfaces. When testing, Pay attention to the attenuation coefficient of the casting. Carefully identify the echo signals formed by coarse grains and uneven structure, so as not to cause false inspection and missed inspection. According to the requirements of castings, we can choose the corresponding inspection method. 1. Defect reflection wave method. For castings with larger thickness and a smoother surface, the longitudinal wave straight probe can be used for inspection, and the inspection is carried out by observing whether there is a defect signal before the primary bottom echo. If it is necessary to detect cracks, or for parts that cannot be detected by longitudinal wave due to the shape and orientation of defects, an oblique probe can be used for inspection, and a dual element probe can be used to detect near-surface defects. 2. Secondary defect reflected wave method. For castings with small thickness and rough surface, the longitudinal wave straight probe can be used for inspection, and the judgment can be made by observing whether there is a defect signal between the primary bottom egg and the secondary bottom egg. 3. Multiple egg method. For castings with thin thickness, uniform material, and the inspection surface parallel to the bottom surface, a longitudinal wave probe can be used to detect through multiple echoes on the bottom surface. 4. Layered inspection method. For castings with a particularly large thickness, the layered method is generally used for inspection. The thickness of the casting is divided into several layers, and each layer is dictated by the depth adjustment sensitivity of the layer. In this lesson, we have learned the ultrasonic testing methods of common PEPs and castings. When we carry out ultrasonic testing of PEPs and castings, we should consider many factors, including the diameter, wall thickness, possible defect types and orientations, probe types, and casting attenuation. That's how we determine the main inspection method and auxiliary inspection method through ultrasonic testing. We can find the problems in the parts to be inspected. Their laws and properties can be found out, the processing technology can be improved, and the inherent quality of the products can be improved in time. That's all for this lesson. Goodbye.